Hi, we're starting these again, and let me just show you something real fast. Okay, we've got a couple of cars there, and now they're starting off. Okay, I'm not going to bore you with the rest of that, but what we have is another situation where force is being used to make something happen. In this case, to make cars accelerate. This is the kind of thing you do all the time. Maybe not as fast as these race cars, but you still do it. So let's take a look at this kind of situation and see how that's different from what we've seen in class so far. Well, here I have my setup here, and what we've done in class before is I said maybe we have something and I'm going to draw it like a dot, and we always have gravity, and maybe there's some force going up on it. Okay? Well, that's what we might have had before, but this time we need to understand what's going on with this problem. And what we have here is we'll still start with our dot, but we'll have a force in one direction and another force in another direction. Oh, that's pretty bad. Let me try that again. There we go. It's a little better, not much. But now we've got another force in another direction. Okay, so how is this different from what we've seen? Well, before we had gravity, and gravity was always acting on it, and we would have to get the force of gravity. And then we would have to figure out how much the other force was pushing up on it to give us our forces, our unbalanced forces. I'm going to start using that term a lot. Our unbalanced forces, which caused acceleration. So let me actually take a problem like you just saw with the race cars. And we're going to see if we can see that problem and work through that problem. And we're going to choose a little bit easier numbers to work with. So when I click here, when I click there we go. They want us to find the acceleration if a 100 kilogram car speeds up from rest on a sandy road. Widen this out. It reaches a speed of 6.5 meters per second to the right in 0.5 seconds. They got a picture there. But I think we can all imagine a car speeding up. So here's the problem. We want to know, we're going to want to know eventually F net. We need to know that. In order to get net force, this can either be all of the forces added together or the mass of the car times the acceleration of the car. But what did they give us? Well, they gave us the mass of the car. They picked a little bit easier number of 100 kilograms. They didn't give us the acceleration of the car. That is a problem. But we do have an initial velocity, and it says it starts from rest. So, how fast is that? Come on, say it out loud. 0 meters per second. We had a final velocity, and it just said that, of 6.5 meters per second. And it said it took a time of 0.5 seconds. On the test, you're going to have a formula chart. This is something I've done often enough that I can just tell you what the formula is here, but I'll get to that in a second. We're going to need our net force, and this is our Newton's second law equation that I want you to get used to using. Sure, on the formula chart, you'll see this. F net equals mass times acceleration. But that doesn't tell the whole story because F net is also equal to the sum of the forces. So depending on what they tell us, we've got to figure it out one way or another. So let me erase that. And now let's go back to what they gave us. They gave us the mass. So there's a good help. Acceleration, initial velocity, final velocity, and time. We don't have acceleration. But with all of these, we can get acceleration. Our acceleration, it's basically the slope of a velocity versus time graph, which is our final velocity minus our initial velocity. And you can say the final time minus the initial time. The initial time is always 0 for these things. The final time, in this case, is 0.5 seconds. So this is 6.5 meters per second divided by 0.5 seconds is equal to 13 meters per second per second. That's our acceleration. Now we can use that to figure out our net force. Mass is 100, acceleration is 13, so F net is equal to 100 kilograms times 13 meters per second, and that equals 1,300 newtons worth of force. Okay, so this is the first one. Notice I didn't even look at the rest of the problem. These are force problems, and when they're force problems, you always need net force. So, well, I guess I was right. It says, what's the net force acting on the car? Actually, in this one, part A, I think I missed it, or maybe I didn't copy it when I put it on here. Part A was find the acceleration. Part B, what's the net force? Part C, if the force applied from the engine is 2,200 newtons forward, what would be the force of friction acting on the car? It says draw a diagram, but I'm asking you to draw a diagram before you start with any of these things. So now let me write down the force of the engine is equal to 2,200 newtons. We want the force of friction. And this is where F net equals our added up forces together is going to work. So we have, and now I'm going to say which way do we have this going? The car's moving, so I'm going to say that to the right. It's moving to the right. I'm going to say that's positive. So my friction is going to be negative. Generally speaking, if they ever say friction, always assume it's a negative. That'll make your numbers always work out good. But my force net is going to equal force of the engine. We know that friction is going to be a negative, so I'll just say minus the force of friction. 2,200 minus the force of friction. And F net, we said, was 1,300. And this equals, well, the difference there, we can move force of friction over here, subtract 1,300 from both sides, and say 900 newtons. This is the same way we solved the other one. We needed to find our net force, whether it's mass times acceleration or the sum of all the forces. Once we found our net force, we would find out whichever other part we didn't have. Here we have mass times acceleration. Other problems, and here we had mass times acceleration, we didn't have the individual forces. But they might have given us the individual forces, and we would have to solve for maybe acceleration or mass. So you can almost look at this, if you like the idea of the guess method, where you just find an equation and plug it in, you can almost look at this as three different equations. Your F net equals sum of all forces. F net equals MA, which is F net, and F net, or sum of all the forces, is equal to M times A. Three different equations. But don't worry about it as three different equations. Just use this one and just look for the things that you have and the things you don't have. I'm going to try and have us practice this a lot during this week. Okay, for this assignment, I know I've been asking you to do something silly, like what's the color of my shirt. But this time I want it to be a little bit more serious. After you're done watching this video, I want you to try and in your assignment box for this, just type in the text, what was this video about? 1 or 2 sentences. And then, what question do you have from this video? Could be as simple as, can you work through the problem again? Or as complex as, what if we had 10 forces acting on this? I don't care. Just some question that you have for this. Okay, that's all I have for this video. Thank you for your time, and may all of your problems have solutions.